Kyryl. I work for DataRobot company. I love asking questions from the audience. Does anybody know about this company, DataRobot? Okay, I can see there are lots of people. And if you look at it, in fact, so I am Kyryl, I work for DataRobot. DataRobot, as a matter of fact, is a data science service. In the past we called it machine learning service, but now we call it data service because it's a completely automated company. So we provide services of processing your data. We build a model for you. You don't need any special knowledge about data science. And then we can select the best model, which on the average will perform better than any manually built model. And it will do it 35 times faster. And besides that, this is about something else on the screen now. I love say when they ask me, send me your title, what are you? I say I'm a programmer. In English it is software engineer. I develop software and I also have operations. Without operations it's impossible for us to survive. I cannot say that I'm not Watson. For another reason, though, that was just by way of intermission. Now, speaking about machine learning, what does a typical process look like? If we break it down into the simplest steps, it is just a pipeline. First of all, you upload the data, then you transform the data. Then you build a model, then you deploy the model on your server, and after that you are happy making predictions. We will discuss the last two blocks here. I will tell you about deploy and predict. The moment once you have built your model and you need to build your predictions. Now, what kind of use cases are there for those who are not familiar with machine learning and data science and all the other things? What is meant by by machine learning? I will tell you about use cases and the differences between them. Each use case has different requirements for the server. The first use case is quite simple. It is what we see actually every day in our spam, in the emails. It is product recommendations, buy this, visit that, and the like. How does it happen? We have our data, what is gathered by Amazon, Google, or Yandex, based on your clicks. They have processed it using a recommendation model. And after that, as an output, they prepare a list of similar products. For those of you who are not familiar with machine learning, it is called unsupervised machine learning. That is to say, learning without a teacher. When you don't know what you want to predict, you want to just understand how the data is interconnected. Next. The second case is more or less clear too. It is predictions, not even predictions. I don't like the word predictions, forecasts, I would rather say. It is price forecasting. It's the simplest way to explain to your grandmother what you do for a living. This is my favorite point. Each one of us has a model inside of our heads, which we use to calculate whether it is expensive or not to rent a flat in a city. It is on the sixth floor of an of a 8-storied building, but there is no lift there. And whether there is a lot of crime out in the streets there or not. Well, you understand that the normal price there would be $300 per month. We think about it at once. We never think about the fact that we apply a mathematical model. It appears to us that we knew about it, but actually this knowledge is based on our statistical information. This is what they call regressive analysis of your data. So you learn the statistics beforehand. Then if you are a real estate agency and you need to forecast something for a customer, how much it would cost to rent a flat. So the input here would be a certain item, that is to say, it could be housing, it could be air flight, and thus you can forecast the price or price changes. But price changes is something too sophisticated to talk about. Another use case, which is quite clear, and somebody might have come across it, and it deals with fraud detection. I don't know how to translate it into Russian. I'm quite sure that those of you who have traveled abroad had situations when you had to pay with your plastic card, but then 2 days after you discovered that your card had been blocked. You went to the bank and wanted to find out what was wrong, and they said, "Why haven't you sent your travel notice to us?" Well, then you say, why should I inform my bank about my travels if I want to use my card? Why was the card blocked? In my life, I had a situation when I slept well for a night, and then the morning after I discovered that $300 had been removed from my card in Jakarta. Naturally enough, I hadn't been to Jakarta, but the fact is that the bank blocked an unreliable transaction because of the fraud detection system. I don't know about all the banks, but the top ranking banks always apply fraud detection measures, and all the parameters then are processed, and based on it a model is built, and the output here is a good, that is to say, approved transaction or declined transaction. And next we have another interesting case, and this is a game engagement. That is it means that if the game is too easy, the person quits it at once. If it is too sophisticated, the person quits it just as well. So it is a response to the behavior of the user and the need to change the complexity. If the complexity of a game is measured on a scale from 0 to 1, we may build a model based on it, which will keep the person interested all along. And we've had this kind of cases. In fact, all of them have absolutely different requirements for the system. What are the complexities here? The first challenge is the time constraint. We need to deploy and respond fast enough. There is a principle described in the pragmatic programming book, and the principle is called good enough software. That is to say, we need to respond fast enough. We don't need to have 15 milliseconds in response from our server to reply which vacuum cleaner we want to buy next. And the second point is that for major businesses, the typical users of our service or of your service that you may build using prediction models, so such users are very big companies which a priori believe that your product should work. If it doesn't work, they wouldn't deal with you. It means that they should get a high reliability product from the box. And this is the way it should be as far as they believe. And I have already mentioned that not all the functionalities are important. For certain businesses, we need short time to respond. For some others, it needs to be fast deployment. And what is meant by fast? 300 milliseconds are good enough for recommendations. It is based on the feedback from our customers. Maybe your service wants to be faster or slower. So 300 milliseconds for recommendations is good enough because if you visit a magazine or a store web page with 300 milliseconds, you will have enough time to send your PR request and get the response. So 300 milliseconds is quite all right. If you build some kind of intricate fintech system and calculate the number of clicks, and based on it you need to predict things, then it should be, the time should be 70 or sometimes even 50 milliseconds. But this is the maximum that you can afford. Otherwise, you would be losing to other services. And the last point is fraud detection. When you swipe your plastic card, it should be done at once. That is, it should be less than 30 milliseconds. And then when I joined DataRobot, I had no experience in dealing with machine learning, but for my university background. And at that time, actually, all the presentations that you have been listening to, we've been speaking about sophisticated databases, etc., and caching, but we deal with the web, and there is nothing too sophisticated there. We need to just put all the bricks together, and then it would be good enough. So I joined DataRobot, and I didn't have the slightest idea as to how it works. Once you build your model, all you need to do is model predict. You have your model object and you put in the data and the model does prediction. If you want to go into detail, then you simply look for the differences between the models. For instance, with second learning as one internal interface, standard has an absolutely different interface, and all of it is done dynamically. That's why you cannot simply look at it inside. Take your time to look at it inside. We have the notion of a black box, that is to say, model predict is what we do within our service. And here's the diagram. I couldn't find a normal a replacement for a CPU. That's why I showed a robot here. So this one looks just like a classical prediction server. It can be even yours. I just replaced some generic terms here, and basically it is shared by other web services.
Then the file system, the RAM and CPU, and different web servers use those components differently. Mikhail used to tell how he uses the file systems yesterday, and at the after party there was a discussion of how to make a request in the respective format, and normally you have one or two components which are critical and you concentrate on them. So it is very rarely that you calculate CPU, and we got used to the CPU being cheap, and it is the rule for a web. Then the file system, we grade something on WS3, we cache it on the local one, and RAM, there might be more problems if we make reports, then the random access memory is not used. But anyway, a large server could be built on WS, and everything could be fitted in, although it will be expensive. Or you can use other options. Though STEP is no different from any other service, and I made 2 slides because I couldn't squeeze it into one. But there are bottlenecks over when you're with machine learning. Each component is a bottleneck. First, if we need high availability, then we want to use distributed file system, and it is actually one large tank. There is FS cluster, and there is it is in Python, but there are a lot of bugs. We tried to contribute patches to it, but it is just broken when the files from the other service are uploaded. HDFS could be used, but it's not cool. There are problems associated with the files having to be with a particular size, and you cannot make it abstract. Get, put, and deletes are quite specific. So the file system, that's where the bottlenecks of the file system are, and they're slow. If you use S3, then downloading file is too long. We use different libraries to build the models. Some of the libraries are our own. We have different softwares, but we cannot serialize it into a common format. That's why we pickle it. And pickling is quite a bottleneck because it is slow and it takes up time. And then pickling model in the RAM is quite expensive as well. And another thing, like they're saying, well, our load is large, we'll make a async IO, but no, you won't manage it, and because prediction is a CPU-bound task. It cannot be asynchronous. you need huge sheets of text. You have to add, multiply, and this should be done in CPU. You cannot delay it, you cannot await it. You cannot do that in the file system. You can make it, but not with the CPU. So all those hype asynchronous things won't help us. And next, the models could be very heavy. People try to use a lot of data with a lot of parameters, and if it is a Python object which will take up all your runtime, then models can be of a gigabyte. It could be a gigabyte object, and so 500 megabyte will be very heavy. And if the model is 500 megabytes, so it can be heavy, or as heavy as 2 gigabytes, or it could be, if it's a text model, then it's 5 gigabytes. If it's 5,000 columns, then at 50 kilobyte of text, it could be a 1 giga object, and those things are very difficult to predict. You cannot know how heavy the model would be. We have a special model that calculates how heavy the models would be, but it's worthy a separate presentation. Anyway, that's what I would like to emphasize, and that's where the Python comes in. And for the first time it tells, look guy, I'm not the one who you need. If you want to have one model for 16 processors in cache, then one model will take up 16 gigabytes on memory, and you cannot do anything about it because it's a Python object and you cannot memory map it. You can even rewrite your models for those models to use special arrays that could be mapped. But who will be using the library to rewrite it, and or in PyArray, and it is virtually impossible to do this job, and it cannot be scaled. But 10 models like that will use 160 gigabytes, and if you use a server with 10 different models, it will use 160 gigabytes. It's too large, too heavy, though you can buy a server like that today. And the customer is saying, what, 10 models? May have 6,000, and that's how little I am ready to pay for it. You tell him, yeah, well, we can try to do something, but not for that little. So the limit to 10 models is no good for us, not acceptable. What are the possible solutions that we have tried? So this particular report is the revision of the presentation of 2015, and Andrei Svetlov has been talking about the German conference. So what's the point? The first solution tells us, let's scale it horizontally, because it's too difficult to scale it vertically. Let's distribute it to different machines, and we will be mapping it accordingly, and the request will be to different models, and we will be routing it which server the model is located. Everything looks, on the face of it, everything looks fine, but what's the issue then? The gaps are increasing. Complexity is growing, and then we have a problem with the utilization of the cluster. For example, if you make up your mind that prediction API will be working like that, hash link, and then a certain number of the machines with different models, and the customer tells you that's not what I need. I need one model for 4 servers, but that's not how hash link works. They just take a certain virtual cluster, and it cannot scale one model to different servers. So the opposite case does not work. What are the possible solutions then that we have tried and have been trying before? First, flatter your models. Though we do black box model predicts, but still we undertake to have a graph format. We try to make it in such a way that it will be possible to serialize model with a lot of parameters, and it will be cheaper than using ping. If we take the library that Misha has been talking about, it's possible to describe the primitives and to load the primitives into memory. That will be great. There's a special format, Fox, and we would like to develop that kind of format, but it is difficult indeed if you are machine learning service provider. You use a lot of different formats, and so it's not possible to write a single protocol to serialize your model. It is quite a challenge indeed. I have been talking about serialization, but talking about flattening models. We accessed the core, and you just wonder how does it work slow, and then you realize it is deep copy of one object. So there's a lot of legacy, and if you get rid of the legacy, you will achieve a decrease. And there's no much discussion about that, but still this code is only 3 years old, but there's a minimum liable code, and then we do the refactoring. We need to develop new features, and that's a reality. We have to catch up with the business, and if you can forget about the predictor model and it works, but then you stop and you cannot move any further without refactoring legacy. And I think that's the thing that you should start. But we have other challenges as well. The customer tells, I not only tell, but I need 0 downtime, and if I have even one request, it will be. We will see. I will take you to court, and then you think that, well, I have a Docker, it's a nice thing, but 0 downtime deployment is very difficult, and the only option is blue-green deployment. It is quite costly, but it is efficient. You have one proxy, you have 2 old and new codes at either at blue deployment or at green deployment. All the smoke testing is done, and then you have switch screen to blue, and green is gone, and the customer does not notice how the deployment is done. It works, but there was one issue because we have cached those models, but in this case we are dealing with the new cluster, and we had to use dirty hacks, and we just launch a Python script that is bombing our servers, and you cannot just tell Python put it into cache, put this Python object into cache, because you have 16 workers for 16 processes, and you cannot tell worker put it into cache. You have to send a certain number of the request before it puts it into the workers. So we just boom the request, and until it gets into the cache, we do not switch it off. It is actually a dirty hack, and I don't like this solution. It is actually warming up cache, but we have not designed anything else. And another problem is like increased load. If we face Black Friday or something like that, you face unrealistically many requests. Everything is fine with blue-green deployment, but one node is deployed 20 minutes. Even if you include it into auto-scaling group, then deployment of this node takes 20 minutes. But it's not auto-scaling. It's ridiculous. And we back it into MAI, and actually it is an image with the code. Every time we have master green, we collect AMI, and we clone this machine, and we start launch all those processes. We have tried Kyiv 8, and you can all Kubernetes everything, but it's not cost effective. If you launch one model in one pad, then it's a separate inside, and the point is that if no request is sent to this pad, it is just idling. But it's one server. You can send a different request. It will take the CPU next door, and it will do the work, and it will distribute the CPU between. And not in this case, it is deploy, and then you have a cluster that costs $300 per hour, and it's not cost effective. So that's why we had to scrap it. Though on the face of it, it looks nice. One model, one pad, but in reality, it did not materialize. And let me tell about the features and other requirements that the customer might have. So monitoring first. We've been thinking sort of there is Zabbix and log station. You can write alerts at on Graphene. But the point is that we have functional and non-functional monitoring. What is non-functional monitoring? Let me first explain what functional is, and then I will explain what non-functional is. Functional monitoring is a straightforward thing. If you have PRG alert and you have fighter, or if it is a high alert, you break SLA. It's more than 500 seconds, it is an alert. And all the other things, errors, monitors collapse, and then there is non-functional monitoring. In the world of data science, there's such an issue as model deterioration. And the model is not valid anymore. We have trends, hypes, and now we offer Coca-Cola. it is a model getting obsolete. It does not comply with the reality, and it is possible to detect it if we gather all the data, we normalize those data, and compare them with with the data available in the trend. And we used the trick. We used new technology like Air Patch, Kafka. It works just 9, and we make intelligence analytics, and it is possible to see that the model is obsolete because the features are not working properly, and the wrong data are sent, and those features should be sent to the customers. So we inform the customers about model deterioration. And another cool thing, when you add all the gigabytes of the information, and then you realize that the model is obsolete, you draw the data from the archives and you develop a new model based on that, and it is nice to have, but we have not done it yet. We are planning to do that in the future. There are companies that are doing that kind of thing. There is Prediction IO, and they are trying to do that, but it is not user friendly. And but having your own Prediction IO and then scale it, it is very complicated operation. It's a new technology, and it does not work well. Like me, I looked into it and I decided that it is better to develop it. And like an outsourced product, it is developed by the other company, and requests and patches cannot get there.
Your questions, please. Are there any questions? It looks like my presentation was not provocative enough. Without questions, that's too bad. Well, thank you very much, Kirill, for a great presentation. I am Piotr. At your second step, you mentioned data intake. As far as I understand, it's a very challenging and important step. So, to what extent can it be automated? Or it is up to the customer? Up to a certain point, it is automated, certainly. Let's say we automate certain things, such as feature engineering. Well, what I mean by automating is that we offer a warehousing automation, or we can offer customized functions. A feature, in fact, is a column. Excuse my slang. Well, you may put in certain functions there. Certain transformations occur there. In addition, we offer our own solutions. And this is automated. It goes without saying, it is actually automated, and this is no secret. The problem may be different, and it is that data gathering is not automated. It's quite a different business model when you need to automate data gathering on your customer's behalf. Nobody but the customer can gather the data. It is the customer's job, but we don't want to say no to this. And just like with any other product, we want the business using our services could improve. And even though we have an other service and we have standard solutions for all the customers, so just like a Photoshop, it's not that we offer one model for one customer and another model for another customer. We are not a consulting firm, but just like with Photoshop, we need to know how to really handle it, and people, even those with some experience, cannot do it straight away from the very beginning. That's why we need to work with every customer just say face to face. We have to work on the customer's problem with them for using our product properly. And when they have data gathering, we work on the customer's side, but we do not automate data gathering. Thank you. Are there any more questions? Well, could it be possible with models where you have deterioration, if the model is deteriorated, could we simply gather the data and regenerate them? That is to say, if we regenerate a model once a day, but if we regenerate a model, it's a separate task. And in fact, it's not so difficult to automate it. But then what happens is that here we deal with people's operations. Just a few words about the way major companies work. They have a team to build a model, and they have a team to build a model, and they also have another team to deploy the model and to monitor its behavior with various data. Just like Dev and Ops, it's two teams. The idea is that with one product, one team says, well, our model has deteriorated and we have already built a new one. So it's not a problem of automation. It's rather people operations. We should understand that we cannot simply replace it. It would possibly be quite cool to replace it even without informing me, but there are very few people who would accept it in real life. And speaking about testing, what about testing? The gentleman is not using a microphone when commenting on it. In fact, validation, model validation and testing is quite a different thing, which is quite apart from production. But deterioration is a post factum thing which happens after you build your model and apply it for production. There is another question over there. Could you please elaborate? What's the Kubernetes problem? What can we do about a cluster which does not receive any requests and is staying idle? In fact, you understand that maybe it was our fault, but maybe we thought that we would have a model for downloading models. That is to say, we're not dealing then with a web service, but rather with a Docker container for this particular model and only for this model. And in this case, we are having a problem because the process may contain any other model inside too. So it is a matter of the status of this container. With Kubernetes, you actually put in the deployed and supported model, and then you can predict only this model and nothing else. And replacing it and getting another container is impossible. If there is a request with a different model arriving, then there will be no response. So essentially, it is just one bot and one model, while with the web server, we may have an n number of models until we get into the memory. So it's just a matter of your working procedure. If you do it just in the normal way, just like with a web service, it would be okay. Yes, that's right. If there are no more questions, then thank you very much for your presentation.